sixth grade, we're going to keep talking about um, relations and functions today. And today we're going to talk about graphing linear functions. Okay, graphing linear functions. The function rule y is equal to 3x minus 5 describes a set of ordered pairs where the y coordinate is always 5 less than 3 times the x coordinate. The value of the y-coordinate of an ordered pair depends upon the value of the x-coordinate. Thus, the x-coordinate is called the independent variable, and the y-coordinate is called the dependent variable. This should sound familiar to you because I know that Mrs. Watson talked to you about independent and dependent variables when you were working on your science fair projects. So the x-coordinate is independent and the y-coordinate is dependent because the y is always dependent upon what is happening to the x-coordinate, okay? Suppose that the x values are restricted to -1, 1, and 3. That means that the only values for x possible would be -1, 1, and 3. By substituting these values into the function rule for x, you can find the corresponding y values and therefore the ordered pairs. A table is often used to help. So here is the table, all right, and we have our x values that we're limited to, which are -1, 1, and 3. And then in the middle of our table, we have our rule, our function rule, 3x minus 5, okay? And then they've plugged in or substituted those x values in for x for each one of those. And then here we have our y values. Those are our output. When x is -1, y is -8. When x is 1, y is -2. When x is 3, y is 4. Therefore, the ordered pairs are -1, -8, 1, -2, and 3, 4. Example number 1 says make a table to find the ordered pairs for the function f of x is equal to x minus 2 if x is equal to -4, -1, 0, 3, and 5. So we have 5 options, okay, for x, okay? The values that we can have for x are restricted to these values. So let's make our table first. X, and then our rule, which is x minus 2, and then our subsequent y values, okay? So we have x, we have -4, -1, 0, 3, and 5. So now we're going to substitute in those values for x. So -4 minus 2. So when x is -4, y is -6. Then we substitute -1 in for x. -1 minus 2, y is -3. When x is 0, 0 minus 2 is -2. X minus 2, plug in 3 for x. 3 minus 2 is 1. And then x is 5. 5 minus 2 is 3. Then we get our ordered pairs, -4, -6, -1, -3, 0, -2, 3, 1, and 5, 3. Skill check number 1 says complete the table to find the ordered pairs for the given function with the given coordinates. Let's make a table with our x values, our rule in the middle, 2x plus 7, and then our output, or our y values, okay? And we have -2, 1, and 4 as our options for x. So 2, substitute -2 for x. So that's 2 times -2 is -4 plus 7 is 3. What about when x is 1? That's 2 times 1 plus 7, that's 9. What about when x is 4? That's 2 times 4 plus 7, that's 8 plus 7, that's 15. Okay, so our ordered pairs would be -2, 3, 1, 9, and 4, 15. Okay, then we have f of x is equal to x plus 4. And our possible values for x are -5, -2, 0, and 3. X plus 4 and y. So substitute -5. When x is -5, -5 plus 4y is -1. When x is -2, y is 2. When x is 0, y is 4. And when x is 3, y is 7. So our ordered pairs are -5, -1, -2, 2, 0, 4, and 3, 7. The x-coordinates selected for a function need not be limited to integers. They can be any real number. So they can be fractions or decimals as well, okay? Make a table of values for the function f of x is equal to 4x plus 1. Let x equal -1, 0, 1/2, and 2. So we're going to make a table. 4x plus 1 and our y values, our output. -1, 0, 1/2, and 2. Okay, so 4 times -1 plus 1. 4 times -1 is -4, plus 1 is -3. 4 times 0 plus 1. 4 times 0 is 0. 0 plus 1 is 1. 4 times 1/2 plus 1. 4 times 1/2 is 2. 2 plus 1 is 3. And then 4 times 2 plus 1. 4 times 2 is 8. 8 plus 1 is 9. Okay, that's how we make a table for that one. Okay, number 1, in box skill check number 2, make a table of values for the function -2x minus 3. X, -2x minus 3, and y when x is -2, 0, 3 over 2, and 5.7. So -2, substitute -2 for x minus 3. So -2 times -2 is positive 4. 4 minus 3 is 1. Substitute 0 for x. -2 times 0 is 0. 0 minus 3. Y is -3. -2, and I'm going to put that over 1 just so you can see what happens when we're multiplying by that fraction. -2 times 3/2, that's -6 over 2, that's 3. Excuse me, -3. -3 minus 3, -6. And then -2 times 5.7 minus 3, okay? -2 times 5.7, I'm going to just write that over here, give us a little bit more room, is -11.4 minus 3. -11.4 minus 3 is -14.4, okay? If the x-coordinates are not restricted, then x can be any real number. A function graphs as a line whenever its form is f of x is equal to mx plus b, or y is equal to mx plus b, where m and b are constants. Okay, that means they never change. The only thing that would change would be the value for x. Such functions are called linear functions. Several ordered pairs must be found to obtain the location of the line on the coordinate plane. Use a table of values to find the ordered pairs needed to graph the line. You must choose the x values to place in your table. You will need at least 2 points to draw a line, and a third one offers a check on your work. Make a table by choosing at least 3 values for x. How many values do you have to choose for x when you are making a table? At least 3. So at the minimum you have 3, maybe you have more, but you always have at least 3, and computing the corresponding y values. If you are asked to make a table and you get to pick your x values and then you get to graph a function and you do anything less than 3 values for x, I will not grade it. It will just be wrong, okay? It will just be wrong. Now, plot the ordered pairs on the coordinate plane. After checking to see whether they all lie on the same line, draw the line through the points. The line contains an infinite number of ordered pairs that form the function. So let's take a look at what this means. Graph the function y is equal to x plus 3. So the first thing we're going to do is we're going to make a table. And because we're not given a set of x values, we get to choose. Okay, you get to choose whatever values you want for x. Now, here's what you want to think through. Do you want to graph fractions? Do you want to graph decimals? Do you want to have to draw a coordinate plane that includes gigantic numbers? No. So when you're choosing your x values, choose 3 values for x that are going to give you an accurate graph, okay, that is not super challenging to graph, right? Not super challenging to graph. So I'm going to go ahead, actually, let me just take a look at what the values that the book chose. Okay, so here's the values that the book chose. -2, 0, and 2, okay? That's a good representation because we have a negative value for x and we have a positive value for x. So we're really going to be able to see what's happening with our graph, all right? Now substitute our x values. So -2 plus 3 is 1. When x is 0, y is 3. And when x is 2, y is 5. Okay? So now we have 3 points that we can graph. We have -2, 1, 0, 3, and 2, 5. Okay, so now we're going to go to our coordinate plane and we're going to graph those points. -2, 1, 0, 3, and 2, 5. Now, because we were not given restricted values for x, because we were just told graph this function, that means that there's an infinite number of options that someone could choose for x, which means there's an infinite number of solutions. So when we graph this, we need to graph it as, as a line, because the line represents all the different possibilities for x and y, because a line moves infinitely in both directions, okay? So now what I have to do, this graph right here, if I just left this like this would not be complete, okay? Even though I have my 3 points, and even though my 3 points are accurate, it's not complete because I have to connect them with a line. And that says it's a linear function and you can choose whatever value you want for x, solve it for y, and it's going to lie on that line anywhere, okay? Now, example number 4 says graph the linear equation f of x, which remember, f of x is always synonymous with y, is equal to 3x minus 1. So we're going to choose at least 3 values for x. At least 3 values for x. I'm checking on what your book chose, okay? They chose -1, 0, and 2, okay? Again, great representation here. We have a negative x value, we have a positive x value, and then it's always good to see what happens when x is 0, okay? So 3 times -1 minus 1, we substitute that -1 in there. 3 times -1 is -3. -3 minus 1 is -4. What about when x is 0? 3 times 0 is 0. 0 minus 1 is -1. And then what about when x is 2? 3 times 2 is 6 minus 1. That means y is 5. Okay? Here's our ordered pairs. -1, -4, 0, -1, and 2, 5. Go to your coordinate plane and graph your points. -1, -4, 0, -1, and 2, 5. Okay? We are not done. We have 3 correctly graphed points. Okay? But we're not done because we have to connect a linear function with a line. That's how we draw that. Okay? Now we're actually done. Skill check number 3, graph the linear function f of x is equal to -5x plus 3. Step number 1, make a table and pick some values for x. So I'm going to go ahead and I'm going to do 0 for x and 1 for x and 2 for x. Now, some of you are like, Mrs. Wilkeny, why didn't you choose a negative value for x? Okay, you don't always have to. You don't always have to. And the main reason I didn't choose a negative value for x is because I didn't want to do a gigantic graph here, and you will see why that would make it gigantic in just a second. Okay, but negative 5 times 0 plus 3. Negative 5 times 0 is 0. 0 plus 3 is 3. Negative 5 times 1 plus 3. Negative 5 times 1 is negative 5. Negative 5 plus 3 is negative 2. Negative 5 times 2 plus 3. Negative 5 times 2 is negative 10. Negative 10 plus 3 is negative 7. Okay? Now, if I would have chosen something like negative 1, that would be negative 5 times negative 1 plus 3. That would be 5 plus 3, and that would be 8. I just didn't want to go all the way to 8, so that's why I didn't pick any negative values. So let's see what happens when we plot those. We have 0, 3, 1, negative 2, and 2, negative 7. 0, 3, just marking some points here. Negative 1, negative 3, negative 5, negative 7, and 1, 3, 5, 7. Okay, so 0, 3 is up here. Then we have 1, negative 2. That's down here. And 2, negative 7. That's down here. I have correctly graphed my 3 points. Now I connect them with a line. Side note, if I would have filled out my table and gotten a point that was out here somewhere, and then I went to graph these, look at what my line would look like. It would be like this, and then like this, and like this. If you get some sort of outlier point like this, you need to stop and say, okay, I've done something wrong, because I know that in this section I'm working on what are called linear functions, which means all of my graphs are going to be straight lines. So if you get something that is going to make your graph not a straight line, go back to the drawing board, because somewhere you have made a mistake. All right, at least 3 coordinate points, at least 3 values for x for every single one of these. Connect them with a line and make sure your line looks exactly like mine. Let me put it in green highlight so you can see it. So we've got the arrow going this direction and the arrow going this direction. This is exactly what your graphs need to look like.